Hello everyone, welcome back to ROBT402. We will continue with pneumatic valves and homeworks. So I expect the students to pause videos and try to solve the circuits by themselves, design the circuit by themselves, test it, and then proceed and see the solution. So um, that's why the videos might look short, but since you need to do them by yourself, so um, it could take longer as you expect. So this homework 4, is about indirect control of double acting cylinder. So again, I try to remind you about the indirect control. It means that we have a secondary valve or control valve that sends a signal or control signal to the main valve and controls the main valve. Positive control signal is manual actuation of course the control lab and the control valve, and negative control signal is a manual actuation of the control valve. And main valve type is 5x2. So I hope you managed to find a proper solution. If not, this is one of the possible solutions. Again, pneumatic circuits could have multiple solutions. They don't have sometimes unique solution, uh, and this is a one feasible solution for the homework 4. So you see that we have one main valve and it's 5x2, so we have 5 ports and 2 switching positions, and we have 2 control valves, and these 2 control valves send a signal, pneumatic signal, to switch the position of the main valve. So by the pneumatic force, we could change the position of spool inside the main valve. So this one is biostable. It means that the main valve could have 2 possible solutions, either uh, either the one on the left or the one on the right, and that's why we call it biostable. So you see that we have manual actuation on both of these 2 control valves, and we have a pneumatic actuation on the main valve. These are basically the symbols that shows ports 3 and 4 are connected to the atmosphere. Um, okay, so let's proceed with the homework 5, indirect control of double acting cylinder. So you see that as we are progressing forward, the homeworks are getting more and more complicated. So you could use the previous one and try to readjust it to the new homework requirements. So having indirect control of double acting cylinder, positive control signal is same as the previous one, manual actuation, and the negative control signal is automatic. So this is something new here for you. The main valve type is 5x2. Okay, so these are some of the industrial parts that could be used in design of pneumatic circuit of homework 5, including double acting cylinder and control valves. Okay, so here is again one feasible solution for the homework 5 in Festoffloid seam. How we could have a sensor feedback and automatic control is shown here. So here we have a simple double acting cylinder. Here we have a ruler, so you need to find this ruler on the left panel. First of all, it's seam, drag and drop it on the rod of the cylinder. Okay, so once you double click on the ruler, then you could choose position of sensors and the area that the sensor is effective. So for example, you want the sensor to be located at the end of the ruler or at the end of the piston stroke. So let's say the piston stroke is from 0 to 100, and this number could be set by double clicking on the cylinder and changing the characteristics of the cylinder. So let's say that you already set the stroke of the cylinder to 100 millimeter. So then you want, for example, to locate this sensor at the end of the stroke, and you want that sensor to be activated from the 90 millimeter to 100 millimeter. So you will double click on the ruler, and you will give a name to the sensor, for example A, and then we'll choose 90 and then 100 to select the range of the sensor. So now you have a sensor which is located at the end of the cylinder stroke. Now you want to see that how this sensor feedback will be used, or where that will be used. So here we have a 3x2 control valve, and here we have a roller. Now if you double click on the roller itself, you could give basically a name of a sensor that roller could be activated by its signal. So double click on the roller and basically enter A at inside basically the box. So now the roller will be activated by the signal coming from the sensor A. So the rest is exactly, or quite similar to the previous examples. We have a 5x2 main control valve, two 3x2 valves. One of them is manual, and the other one gets a signal, or will be activated, I could say, by the signal of the sensor A. So once the rod is at the end of the its stroke course, then the sensor A will be activated, and then this valve also will be activated. So now what's happening here, if we push this lever here, then the cylinder will go forward. Once it reaches to the end of its stroke course, then the sensor will be activated, and the other valve will be activated, and then the main valve will switch. If you release this control, this lever here, and then the cylinder will retreat back to the initial position, and that could be repeated by, again, the manual actuation and the automatic actuation. The manual one was the positive control signal. It means that the cylinder will move forward, and the automatic was the negative control signal. It means that it will retreat back the piston to its initial position. Okay, now that you are familiar with the automatic control, we could have more complicated example of placing sensors on cylinders. So please try to accomplish this circuit on a Festo fluid sim, and again you should submit all of these homeworks once done on Moodle. Homework 6 is about indirect control of double acting cylinder. So same as the previous homework. However, for both positive and control signal, we expect to have automatic control, and the main valve type is 5x2. These are some industrial parts that could be used in real applications and real pneumatic circuits. Okay, so here we have one feasible solution. Since we want to have both forward and backward to be automatic, we need two sensors, one at the beginning and the other one at the end of um, the stroke of the cylinder. So I'll just remind you with the previous previous lectures that we had and videos. For example, on MPS 500 stations, on many of them, I could say all of the double acting cylinders have two proximity sensors, one at the beginning and the other one at the end of the cylinder stroke. So here we are trying to simulate that sensor positions. We gave a name of A and B. Again, you need to place this ruler, double click on the ruler, choose two names, label name for sensors, A, B. You could call it whatever you wish, B1 and B2, for example. Now you need to specify the range of the sensor where that sensor will be activated. For example, sensor B, you want that sensor B to be activated once the rod is from 0 to 10 millimeter of the stroke. Once the rod past that range, that sensor must be deactivated, otherwise it could conflict the control signal from the other sensor. Now you have two 3x2 control valves. If you double click on the roller here, you could assign a sensor to the roller. So the roller will be activated by the control signal coming from the sensor. Again, it's a simulation. It's not perfectly same as the real application. So another way to imagine this configuration on a real system is that these are, let's say, micro switches, okay? And these micro switches or rollers will be activated by a mechanical contact between between stroke and the roller. So for example, here you see that the Festo fluid sim is putting this wall or mechanical, let's say, barrier here on this roller. So it means that this roller is activated by the sensor B at this time. Okay, so once the rod moves forward and reaches sensor A, then you will see this symbol on this roller instead of the other one. So here now we have automatic forward and backward motion. If you manage to perfectly design this circuit inside the Festo fluid sim software, then you will see that this rod basically will go back and forth continuously. The next homework 7, is about indirect control of double acting cylinder. Very similar to the previous ones. Positive control signal as automatic, negative control signal automatic. However, we want to be able to stop and start this automatic motion, okay? Because in the previous one, we didn't have any control on the cylinder movement, and we couldn't stop it or start it. But here we want to have a start using a lever operated valve. And the main valve type is same as the previous one, is 5x2. Okay, so here we have a solution, one feasible solution again. We have a 5x2 main control valve and double acting cylinder. We have a roller and sensors at the beginning and the end of the stroke. And we have two control valves. We have a basically mechanical roller on them, and we assign these sensors to these rollers, the mechanical rollers A and B. At this time, the sensor B is sending signal to the roller, or I could say this roller is mechanically involved with the stroke. So that's why we have this symbol here. Okay, so you see that very similar to the previous one. However, we added one extra 3x2 control valve here, and this one has a manual actuation and is basically a spring return. So to open a pathway from 1 to 2, we need to activate this valve. Okay, so once you activate this valve, this pathway will be open, and then this automatic movement will happen. Okay, and if you want to stop it, you just release this start button. Okay, so we have a homework here that the solution is not provided, so I expect students to come up with the solution themselves. You need to draw the pneumatic circuit of the sorting station. So what was the sorting station? It was the last station in the MPS 500 where we will get different parts with different colors, red, black, and silver. And sorting station task was to sort these parts based on their color and material. So I strongly recommend you to back and watch the sorting station video that you have on Moodle, or review those YouTube videos that I provided for, I guess, the second session, and I explained that what are the tasks of sorting station, what are the sensors on that sorting station, to better understand the functionality of the sorting station. So once you have done that review and you manage to locate all the sensors, then you could come to this homework. So you want to draw the pneumatic circuit of the sorting station. Use two double acting cylinders and two 3x2 directional valve. So we had two double acting cylinders to basically guide parts to the first and the second slide. And the third one, once none of those guides are activated, parts could go to the last slide. Um, okay, so the solution could look a little bit complicated. So that's why I provided a solution here. So it looks easy, but once you start to do it in Festo Fluid Sim, you might face some issue. This is a service package. You could ignore this one. Okay, so you could ignore this one. I just try to be as much as possible uh, or have as much as possible similar circuit to the real one. So that's why I put this service package here, but you could avoid this one. Just simply connect the compressor to your valves. Then here we have valves. We have one, two, 3x2 valves and one 5x2 valve here. And these are basically check valves. Again, for now, you may want to ignore these ones. Check valves are used to control the speed of the cylinders. We will have in coming sessions. I will explain what are check valves. And then we have two double acting cylinders. Here we have the electrical circuit. We have solenoid, a 1M1 on this valve. So you see that this one is pneumatic and a solenoid. So that solenoid will open and closes the gate to the air force or to the air circuit. So we have the solenoid 1M1, 1M2, 2M1 and 2M2, and we have basically here sensors. Okay, we have sensors here. Okay, and basically these solenoids will be activated by the command of the sensors. Okay, I will, so I expect you to work on this circuit. Once you spend some time, I will provide the FestoFluid Sim file on Moodle, so you could open it by yourself and see how it works, and then you will have a better understanding of the pneumatic electrical circuit of the sorting station. And later, as exercise, you could start to simulate pneumatic circuit of other stations. Of course, I will give you the schematic diagram of stations, and then I will expect you to replicate that diagram, pneumatic diagram of those stations in FestoFluid Sim. Okay, so it was the end of directional valves sessions. So again, as we have lots of homeworks, I expect students to spend time on those homeworks to understand exactly directional control valves and different type of pneumatic actuations and how to work with FestoFluid Sim. And then you will have an assignment on Moodle to submit all of these homeworks. Good luck with homeworks, and see you in see you next session.